Hello everyone, welcome back to another calculus video. This video is for my current Math 265 students, that's Calculus for Engineers, and today we're going to be talking about some problems from section 2.5, which is about the chain rule, but in particular I'm going to give some help with the trig function problems. So let's get started. Here I have two derivatives. I have the derivative of sine of x, which is cosine of x, and the derivative of cosine of x, which is negative sine of x. If you'd like videos on the proofs of either of these, let me know. But my perspective for these problems is I want to go through this with as little memorization as possible. So I will say if you're not going to memorize, how to prove these things, you might as well just memorize these two. But once we have those, we can really go a long way. One thing I want to show you is if you get confused with which one should be positive and which one should be negative, well, let's look at the graph of sine of x at 0. And if I draw the tangent to sine of x at 0, it's this line here. And notice, well, that has a positive slope, right? So cosine of 0 is 1. So the slope of this line is positive 1. So if this was a negative here, the line would be going the wrong way. So that's how I, remember that when I take derivative of sine of x, I get positive cosine of x. And then for derivative of cosine of x, we get negative sine of x. So you could go ahead and memorize the derivative of tangent of x, but I want to show you how to derive it. Now, one more thing I think is worth memorizing is the following trig identity. So I think this is one of the most important ones. I'd argue it probably is the most important one, but it's sine squared x plus cosine squared x is equal to 1. If you'd like a proof of this, just let me know in the chat. I was thinking I could tell you a silly word to say in the chat, and then I'd know that's what you'd want. Let's say elephant, so type elephant in, not the chat, I guess, the comments if you want a proof of this identity. But okay, using this identity and what we know about the derivative of sine and cosine, let's figure out what's the derivative of tangent. I'm going to add a new page. So let's remember, how do we define tangent of x? Well, it's the ratio sine of x over cosine of x. And well, here I could use quotient rule if I wanted to take the derivative, but I'm more of a fan of product rule plus chain rule. And what I mean by that is writing this as sine of x cosine of x to the negative 1. Now here I do not mean the inverse cosine function or cosine, I mean 1 over cosine of x. So let's take derivative now. So d dx tangent of x. This is going to be equal to, okay, so it's going to be product rule. Let's take derivative of sine. We saw that's cosine of x. Now I have times 1 over cosine of x, so over cosine of x. So again, I'm doing product rule here. Take derivative sine of x, leave 1 over cosine of x alone. Now plus, leave sine of x alone. Take derivative of 1 over cosine of x to the negative 1. Well, it's going to be negative 1 cosine of x to the negative 2. Now chain rule, right? I have to take derivative of cosine of x. So it's going to be what? Negative sine of x. Very good. Let's do a little bit of cleanup. Well, cosine of x over cosine of x is 1. It's going to be 1, and then minus 1 minus, those minus are going to multiply to positive. So now we have plus sine squared of x over cosine squared of x. And this is 1 plus tangent squared of x. But if you were to look up a table of derivatives, and you looked, at the entry for tangent, this isn't likely what you would see. And let me show you how to put it in a form that you probably would see in the textbook. So let's remember our identity. 1 is equal to sine squared x plus cosine squared of x. And if I divide across the board by cosine squared of x, I get 1 over cosine squared of x is equal to sine squared x over cosine squared x. So tangent squared x plus cosine squared x over cosine squared x, that's going to be 1. So notice this matches what we have here. And well, 1 over cosine of x is secant. That's how we define secant. So 1 over cosine of x equals secant of x. So 1 over cosine squared of x is secant squared of x. So the way that you'd see this most likely written in the book is secant squared of x. All right, very good. So again, if you don't want to do this computation every time you need the derivative tangent of x, then, go ahead and memorize secant squared x, but also remember this trig identity, and that's how you can get this other one here. So, okay, very good. That's derivative of tangent of x. I'd like us to do this problem from section 2.5, and it's saying match the functions and their derivatives. So, well, we just did y equals tangent of x, and we said, oh, well, that's secant squared of x, which is equivalent to 1 plus tangent squared of x. So it looks like 1 and D match, so let's connect those. Perfect. And now let's see what we can do with the remaining 3. So we're going to need space for these, but let's start with cosine cubed of x. So I'm going to copy this and add a new page. So this is going to be a chain rule, right? Because it's cosine raised to the power of 3. So when I take the derivative, so y prime equals, now outside function is x cubed, right? I'm cubing something. So it's going to be 3 cosine of x to the power of 3 minus 1 is 2. So 3 cosine squared of x. Now chain rule tells me I now need to multiply it by the derivative of the inner function, which is cosine of x. And well, we know from before that's negative sine of x. And if I just rearrange, this is going to be negative 3. Let's put sine first. Sine of x cosine squared of x. And hopefully, this shows up in our list of things to match. So let's see, negative 3 cosine squared of x sine of x, c. So we're going to match 2 to c. Perfect. And then that leaves 2 more. So let's now try cosine of tangent of x. So this is going to be another chain rule, right? So let's paste. And all right, let's see. And, just so we don't get confused, let's kind of box this off. Perfect. Okay. So, all right, y prime. Now, outer function is cosine of x, so derivative of outside function, negative sine. Now, leave inside function alone, so tangent of x. Now, multiply times derivative of the inside function, which is tangent of x. And we saw tangent of x has derivative secant squared of x. So I'm going to lock in the answer of negative sine of tangent of x multiplied by secant squared of x. And let's see where that shows up. All right, so we have, does it appear anywhere? Okay, look. So B, negative sine tangent of sine of tangent of x. Now it's saying divided by cosine squared of x. Well, what's secant squared of x? It's 1 over cosine squared of x, right? So this is the same thing as negative sine of tangent of x divided by cosine squared of x. Very good. So that tells us that 3 matches to B. Now, it's a matching problem. If this was a test, you would match 4 to A and then you'd be done. But let's take the derivative just to make sure we're all on the same page. So let's copy this. And let's do one more. All right, let's see. So we have sine of x times tangent of x. So this is just a product rule. So then y prime. All right, this is going to be, let's take derivative of sine of x. So cosine of x, leave tangent alone. Tangent of x now plus, I don't know if you can hear the loud sounds outside, but I'm sorry if you can. All right, now let's leave sine alone. Take derivative tangent of x. Sine of x. Now, derivative tangent of x is secant squared of x. And let's see. So something tells me we're going to want to change this just a little bit. I am sorry if you can hear my cat. All right. I'm going to use some editing magic to take out my cat meowing really loud. But okay, let's clean this up a little bit. So we know tangent is sine of x over cosine of x, right? So what's going to be left here is just sine of x from this equation. So again, let me just kind of show you really quick. This is cosine of x times sine of x over cosine of x. So these are going to go away. All right, so here we have sine of x plus sine of x secant squared of x. And let's factor out a sine of x. So this is going to be sine of x times 1 plus secant squared of x. Let's see what the answer gives us and see if we can fit it into that form. So let's see. Sine of x plus tangent of x, secant of x. Let's see. Oh, I see what they want us to do. All right. So let's erase here. And I'll leave it actually. So that's one way. That's not quite what they wanted. Another way we could write this, so I'm going to go back to this equation. And they want us to do, okay, we're going to have sine of x plus, now let's remember secant squared of x is going to be sine of x over cosine squared of x. So this is going to be sine of x plus, now sine of x over cosine of x, that's going to give us a tangent of x, and we're going to be left over with 1 secant of x, so 1 over cosine of x. And that's the form that they wanted it in. So I think the tricky part about this one is they wanted you to really practice getting these trig functions or these trig derivatives in very specific forms. But other than that, I think that's where I want to stop the video. Like always, let me know if you have any questions or ideas for future videos, and I'll see you in the next one.